students ask me all this ID I've mentioned before, isn't it? Because Excel cannot read, Excel can read the name of your variable, but in terms of the value must be numerical numbers. So you cannot type Maybank, Berhad. Normally we don't do that. We will give assigned code. But actually, I've shown you on Eview's. Eview will assign the own code for you, but you want to make sure the code correspond to yours, right? So Eview will assign the ID and the year actually, right? But you can put it in to make sure that you know which one is Eview's referring to. But the main thing is to key in your results. And I've mentioned, I think, right? When you key in your results, we use the stacking process. You can see here, if you're talking about either company or country, doesn't matter. We will start with one, let's say we go company level. This is company A. We will do for company A, then all the year study period, let's say from 2003 to 2011, we settle for company A first or for country A first. After that, we go downwards. That's why we call it stacking. I think when you were kids, you play stacking, or not? Maybe wooden blocks or whatever, right or not? We stack, meaning one on top of another. So after you finish number one, then you go to company number two, right? For all the year, then you go to company three and so on. So we stack. So if you got 100 firms, 5 years, so you will have until 501 because the first one is the name of the variable. You understand? So it will be a long list. Okay? So all this I taught you already, isn't it? Then how to create a work file, all this I taught you. But remember, for now, I'm demonstrating using a balance panel option because if you do for 100 firms, 5 years, right, no missing years, that's called a balance panel. But you notice later, when we want to do our diagnostic testing like heteroskedasticity, autocorrelation, you can do using balance panel, but the command or the test used are those maybe you're not familiar with. The one that your economic metrics lecturer normally don't teach you. You see some tests that you never see before, right? So for familiarity, the one easier to understand, if you don't want to go balance panel, you go straight undated. Meaning you don't need to, you don't need to do balance then change to undated. I'm just demonstrating balance panel. Later you see I do undated. Both can work, right? So to save your time, actually you can go straight into undated. Very excited there, right? You can go straight into undated to save your time. But I'll show you later the undated how to key in. Okay? So all this I've shown you already. Then how to, create this empty sheet, how to paste the data so you follow only. Descriptive statistics I have shown you, right? Some students say, look at what? Be mindful. I highlight the area means this is the one you will later extract to put into your final table for chapter 4. Okay? I'm not sure whether your notes are highlighted or not. Are they highlighted? Yeah, then already, right? We only extract the highlighted one later. Meaning the software will give us more than we need, so we only extract the relevant one. And when I show you the sample project paper, I will show you how we arrange the data into the format that we normally require. But as I've mentioned, never copy-paste the software output directly into chapter 4. I only have one word to say if you do that, lazy. Yes or not? Lazy, right? Cannot produce again, just copy paste straight away. Okay, so don't do that, right? I've also shown you on how to come up with this correlation table, and we only look at the top, isn't it? The top stands for correlation coefficient, right? Not Pearson correlation coefficient. Okay, and this is the one where for multicollinearity, we make sure between our independent variable, the correlation is less than 0.8. Remember? Okay? It is based on the yellow one. The one at the bottom will stand for the p-value, meaning that's the one you will convert into star lah. Like 0.9, remember our benchmark, 1, 5, 10%. This one I think is based on 5%, right? If let's say later you see in my sample project paper, normally we just put compared to 5% because this is not the real regression results. So if you get a p-value of 0.9237, it means no star because already exceed 10%, isn't it? 0 means very good isn't it, right? Because this is significant at 1%. Depending, you can put 3 star if you want, right? If you not, you just want to standardize to anything more than 5%, 1 star, then you put 1 star. That is what you see in my sample project paper. Okay? So where to get all the star, you look at the p-value at the bottom, but you convert it to star. You understand? Put the asterisk by yourself. Okay? Right. Then I taught you how to estimate the equation. Basically, you have to type this into your software. How this works, the first one is always the dependent variable. Depending, just now what symbol you type, isn't it? You must follow. C is the, suddenly the word cannot come to me. C is the what? Constant, right? Constant, right? And then the rest will be your IV and your control variable. Meaning you follow the model that you have constructed in 3.2, isn't it? 3.2, the equation, it should be the same as this, okay? And this you will paste into this area, isn't it? And the rest are already by default setting, so you just have to make sure panel option none. None means it's OLS, right? Then you type OK. But I did mention as my concluding, this is the concluding page, isn't it? In the last lecture, you will get this, but remember this is not the final regression model. Don't be so happy or don't be so sad if you don't get the result you want because you haven't done all the diagnostic testing yet. This is just the initial one. But I will use the initial one, I highlight, meaning all these are the areas later you have to extract and put into the table in chapter 4. Okay, right? So now we are going into the diagnostic test. Okay, the diagnostic test. So the first test is normality test. So you just follow, right? Because SPSS Eviews are window-based, software, so they're very friendly. You don't need to remember any computer programming command, isn't it? You can, if you don't know, so you click until you find it, right? Right now. So you just click View, Residual Diagnostic Histogram Normality Test, and you'll come out with this output. What we are interested in, unlike SPSS we really look at the histogram, normally distributed or not, symmetrical or not. For Eviews, that is not the important thing to see. The important thing to see is the one I've highlighted. The Jack-Barra, especially the probability. Remember in Eviews, probability means p-value, isn't it? Right? So we look at the p-value of your Jack-Barra. And here I've written the so-called the guideline, right? So if your p-value is less than 0.05, meaning significant, it means bad news. Bad news, meaning our data is not normally distributed. So is this good or is this a problem? Problem. So you have to see where's the problem. So I did mention in one of my earlier classes, for all the problems you face in your diagnostic test, the remedial action, isn't it? So if you have this situation not normally distributed, so what is the correct action to take? What do you do? What to do, Some forget already, that's why we want this to refresh your memory. If I get this not normal, isn't it? I say, at every stage in your diagnostic test, if you cannot pass it, you must solve it first, isn't it? You cannot just report, not normal, then continue. You cannot, meaning all your later results are questionable, isn't it? Because this part already got problem. So how to solve this not normal distribution? That's where be careful. Remove the variable is dangerous, as I've experienced in my morning class, isn't it? Where's my morning class? The one remove the whole variable. Friends at the back. Now sometimes I don't blame the student because the word can be misinterpreted, right? That I just share. I won't name which group, after you shy, right? Okay, right. So they have this problem. So they know must remove something, but they remove the entire variable. You understand? Like let's say control variable font size, they remove the entire font size. Is that what you should do? No, you just remove what? That particular extreme value. Meaning you will be checking through your Excel every column, isn't it? So let's say under ROA, let's say you got ROA. ROA, you see normally the range is negative 10 to positive 10. Then suddenly got one figure, positive 2000. Wow, 2000. Abnormal, isn't it? So that is the meaning of how you can just use your physical check. You can see when the value look like very out of the norm, right? So what you do, you just remove that particular figure, delete as easy as that, delete it, you understand? Okay, right? So you remove that particular value. You don't remove the variable, after end up no more variable, you everything chop, then end up, hey, got one IV, one DV, nothing else already. Wow. So minimalist, right? Cannot happen, okay? So normally, by removing, it should improve the situation, right? Unless the sample size is really small, as I say, maybe you're only doing banks, and maybe, for some reason you can only do banks in Malaysia, 8 banks only. No choice, because no other local bank, and the situation or the problem is unique in Malaysia. So 8 banks, very high chances you cannot get normal. So that one you can justify, okay? That you want normal distribution.
괜찮아,